Sorry, the sound is not going through. Now you can start again.
Sorry, we had technical issues. So welcome to the IGLUNA project show. IGLUNA is an international student platform coordinated by Space Innovation and bringing together the student teams from all over the world to develop the technologies relevant for the future of space exploration. Our guest today is the team P04 from Warsaw, and they will be telling you about their experiment to terraform the lunar soil to be able to grow the plants on the moon. We will start with a short video about the project.
Hi, Sample Tutin here. We are students from Warsaw University of Technology. We are going to walk you through our journey.
Would be lettuce, cress, rocket, and endive. And in order to control the factor that could make our plants not grow in the module, we decided to plant our species in different conditions. And the first option would be to plant the plants in normal soil and without recirculation. The second option would be to plant the plants in terraformed soil, simulating lunar soil, also without recirculation. The third option would be to plant the plants in normal soil, but with recirculation. And our key option, our final option, would be to plant the plants in terraformed soil, simulating lunar soil, and with recirculation. And that way it will be easier for us to find the source of failure if some factor fails. And thanks to that, we will be able to modify our experiment and to adapt it to the needs of the plants and to the requirements of the module.
After all research, we begin our small sample experiment. We sterilized soil, organic compounds, water, and created a simulation of model on smaller scale. We put everything in the glass jar, closed it tightly, and we put it under UV lamps. After some time, we opened and checked how plants did grow, measured the amount of sprouts, and evaluated how they look. We also observed the terraformed soil under the microscope. Finally, we compared the results of our experiment with standard soil with the same pH level and with lunar soil regolith without bacteria. In conclusion, we think that our project has huge potential, especially when it comes to increasing a number of microorganisms.
Now we are going to talk you through the mechanical part of our experiment. In order to sustain sterile conditions and to prevent any contamination, we have built an autonomous module capable of sustaining plants' life.
Our module is built from aluminium profiles and aluminium panels. To make it watertight, we covered all holes and connections with glue and silicone. The top cover is screw-on and we enforce it with a gum gasket so that no water might leak inside.
A layer of isolation is placed on the exterior to help sustain the optimal temperature inside. We've covered the module with a silver heat blanket that may reflect heat, and also we've put a radiator on the top. It was done to make sure that the module...
Thank you very much. So given the idea of terraforming the lunar soil, can you still think about applications for Earth?
So for Earth, we think about fertilizing Sahara Desert, for example. Also, the unfertile soil, we can create a procedure to refertilize it. Also, the limitation is in our head, like we can use it anywhere we want. If we want to plant some vegetables on Arctica, sure, why not? We are analyzing for now what is capable or what is not, but we believe that this experiment has huge potential right now.
Great, well, that's really nice to see you're so motivated about your project. So during this year, what was your biggest challenge with the project?
Probably access to laboratories due to COVID. The COVID restrictions hit us really hard, especially the biological part. We couldn't access the clean rooms, but it was a challenge, but we managed, and we have the terraformed soil right here with us, and we have some promising results so far.
Great, thank you very much, and it's really nice to see your project here on Pilatus. So somebody is asking, how difficult is the terraforming process?
For now, as we call it, terraforming process is on the concept phase. Right now we are checking exactly what's happening on the soil more empirically. After that we'll do some equations to optimize it. It's really difficult because our lunar soil regolith has a lot of particles, which in some cases, when other groups tried just to plant some vegetables and fertilize it, they were removing a lot of parts, and we have like the best available regolith right now, and has everything in it. So there's some glass particles which are really difficult for plants to cope with, and also for microorganisms. For now we just looking what's happening and we try to adapt, but for now it's quite difficult road, as I would say.
Great, I see. And maybe staying on the topic, how is your project here on Pilatus going on? Would you like to say a few words? What was happening in the past few days?
So for the past few days we are analyzing data about temperature, soil moisture. We have the live view from the camera. However, we are not able to see everything as good as we would like to. We think that there is some plants on our regolith and on the soil, but we cannot say it for 100%. Yes.
Yes, everything is running. The remote control is actually really good, and we have the live view from the module inside, so we're really happy with how it turned out.
Thank you very much. I see that somebody is asking how much soil do you need to create to grow one plant?
It's really hard to say because the most important part of the terraforming project is to terraform it. It depends on the thing. But for now so it's like about 300 terraform simulant on the thing soil on. So for now we are more concerned about terraforming part than for the amount of terraformed soil.